Hi, here we go with a hopefully quick section 1.4 summary. What you see on your screen right now are all the parent functions that you need to have memorized if you don't already. With the exception of the constant, that's pretty much a linear, so the first two pretty much go together. But you need to know that an absolute value looks like a v and that the square root function looks like it does. Same thing with quadratic and cubic functions. And so 1.4 was basically about using our knowledge of what the parent function looks like and then applying some general rules about how we can transform graphs and do a quick sketch of what looks like a very complicated function, but we can make it easy by using these transformation rules. And so I'll ask, I've got it up on the screen right now if you need to pause and make sure you've got this down. This is very, very important. It describes the role that each little thing in this equation, the role it takes in its transforming. And so what we're going to do is we're going to look at the parent function of a quadratic y equals x squared. And we're going to look at first a very basic transformation, y equals x squared plus 4. That means you start with this right here, this y equals x squared. Okay, we're going to move the, all right, I really wanted to move the graph. There we go. So this 4, because it's by itself, you're going to be moving up. You're going to take the vertex, which is right at the origin, and you're going to move it up so that the vertex lies on 0, 4. And that's just the basic transformation there. Here's a little bit more. We see this -3. It's always the opposite. This shifts left or right, and it's always the opposite of what you think. I told 7th block that when the number is right by its x, like when you're by your x, you're going to act the opposite of how you're really feeling. Probably not really good, not really a good recommendation to do, but it's kind of fun to remember, okay, this -3 is by its x, and he's going to go like, oh, everything's cool, everything's all right, even though maybe he's feeling quite negative. Okay, so I see the -3. I'm going to go back to our parent function. So we're going to look, I like how my arrows aren't attached. So we're going to look at the parent function, and this -3 says, move the vertex 3 to the right. Okay, so we're going to move it 3 to the right. Then this 1 happens to be single. It is not by its x, and it can do as it wants. If we see a +1, it means +1, move up. So all we've done here, even though it looks complicated, is we've used our knowledge of transformations to sketch this graph just by moving the vertex over 3 to the right and up 1. Okay, I'm going to have to take my parent function somewhere else. Well, maybe I'll just leave it there. So this one, I've got a quadratic who is moved, the vertex is moved 1 to the right, and it's got a 5 in the, I call it a slope, even though quadratic really doesn't have a slope, but it's in the slope spot. So what that means is that we're taking the quadratic, that, the parent function, we're going to move the vertex to +1, and we're just going to make sure, since our original parent function had 1 as the quasi-slope, and this one has 5, we know the bigger the number is than 1, the more steep it's going to be. So I just need to make sure I draw something. All right, caught on something. I must have a little bump there on my smartboard, but it shouldn't look like that. It should look more like a U, but the U should be nice and steep, steeper than the parent function. Okay, and this next one, we've got the same thing. We've moved the we moved the vertex over to a negative, well, not -1, to a +1, to the right one, because we're always doing the opposite when we're by our x. And the 0.25, we've got to remember this. When our slope, our fake slope falls between 0 and 1, this gives us a very wide, and it's less steep. So we're going to go ahead and just imagine that it's going to be much less steep than the original parent function. Okay, do you have to be perfect on these sketches? No, you do not. You just have to have the idea. The vertex has to be perfect. You have to know if you're moving over to the right one, well, your vertex has to be there. But as far as the steepness goes, no, it does not have to be perfect. It's just a sketch. Okay, and then we're going to talk about let me get rid of that. So now we're going to look at this. Let's move all these up. So we're done. So let's look at this one. So once again, we're just moving our vertex to the right. And apparently, we're just going to ignore up or down, but we're moving it to the right one. And then we see this -2. Okay, the 2 tells me that I'm going to be more steep than my parent function. And the negative tells me that I'm going to flip over the x-axis. So when we see a negative that comes right after the equal sign, that negative tells us to flip over the x-axis. So what we're going to do is we've already moved our vertex over 1. The negative tells me I'm going to flip over the x-axis, and I'm going to be just a little bit steeper than my parent function. So maybe something like that. That's probably a little too steep, but once again, we're just sketching, and that's okay. And let's see if we have one more. Oops. All right, let me get rid of this. Okay, so where'd our one more go? Here it is. Okay, lots to do here. Let's move up the screen. Okay, we're going to move our vertex. First, we're going to move it to the left 4 and down 3. So we're going to take our vertex, which is always our parent function's vertexes on the origin. So we'll move it to the left 4, 1, 2, 3, 4, and then down 3, 1, 2, 3. This is our new vertex. So always this number that's by the x and this number that's alone at the end, this shows us the way to move our vertex. So to the left 4, down 3, and when we're done with that, we see that we've got a negative slope. So that means we're going to flip over the x-axis, and the 0.25 tells us we're going to be quite flat and wide. So there's our new vertex right there. So we're going to be going upside down and wider. Once again, that might be a little too wide, but a sketch is a sketch. We are not graphing calculators. We are humans making sketches. Okay, let's look real quickly at the square root of x. That's the parent function that you see on the screen. And so when we're changing it, I wanted to talk about this. Obviously, you can do the same things transforming. In fact, I'll probably add some in just a second, but I want to talk about when we flip over either the x or the y-axis. Here you see that we've got the negative right after the equal sign. So it's not right next to the x, it's right after the equal sign. Once again, that means we flip over the x-axis. Okay? What would that look like here? It would basically look like we're just going to take it and go flip over the x. So it would look something like that. So that's the new function that represents this equation right here. Okay. Wonder if instead of our negative being outside right next to the equal sign, it's actually inside the square root sign right next to the x. Well, if you already have memorized that if it's a negative right after the equal sign and that's flipping over the x-axis, then you know this is going to be flip over the y-axis. And a really cute way to remember this is when the negative is right next to the x. It's kind of like your x is being negative. And so you're like, there's no need to be negative. I mean, why? Why does my x have to be so negative? Your x as in, that kind of x. So Why does my x have to be negative? So negative, that says y, and that reminds you of the y-axis. Oh my goodness, my original square root went away, didn't it? All right, let's see. That'd be 0, 0, 1, 1, and 4, 2. So here's my parent function for a square root. And so if the negative is next to the x, we're going to flip over the y-axis, and we'll look something like this. Okay. Once again, if we want to do something more involved, this time I'm just going to use the eraser to erase, so I'll get rid of my parent function. If we want to do something more involved, like y equals negative 5 square root of negative x plus 4 minus 1, we can use the same thing, the same transformation moves as we were doing with quadratic. Basically, this point right here is our point that we shift around. And so when we look here and we're shifting 4, so of course we're going to do the opposite because we're by our x, we're going to act the opposite. So we'd shift the vertex over 4 to the left. And then here tells us that we're going to shift down 1. So here's our new point. This is the old point. This is the new point. And then it tells us our negative coming right after the equal sign. We're going to flip over the x-axis. I'm sorry. We're going to flip over the x-axis. And let's see. That's a 5. So instead of looking, I'm going to do a couple things. I'm going to draw my original here. Okay, that would be my original if I just shifted my beginning point. And then to flip it over the x-axis, that would have me looking like this. And then what else do I have to do? Oh, 5 means it's more steep. So I'll make it more steep, something more like that. Okay, so this blue one is the final sketch that matches up to this. So it took a little bit more. That's my parent function. This was the, if I just had y equals the square root of x plus 4 minus 1. This one was the, if we had just the negative of the square root x. Oh, I'm not done with I'm not done yet, am I? Okay, I'll just keep going this way. So this one is my, let's see, I flipped it. That's all I did with it. Okay. And then this one is not what I said it was. This one is if we put the 5 there. So that'd be y equals 5. You know what? Let's see. Negative 5, and then we'd have that. And so what we're going to need to do, our very last one, which I'm going to sketch in black, would have us shifting. We've already shifted over the x, so now we have to shift over the y. So it would look something like, let's see, we'd be over here on the 4, and we would be more steep, so something like that. That's our final one. Whew, that was a tough one. So if that was confusing to you, that's okay. We had to do a lot of different shifts there. All right, and then 5 minutes. Here. All right, hold on one second. I'm gonna pause. Okay, I gotta pause. Someone walked in the room, and I will be right back with you. Okay, and I'm back. Let's go back real quickly to that crazy mess, this last problem that we did. That was kind of fun, but I don't want you thinking this is the type of problem that you're going to see on a test. You are going to be asked things that test whether you know the difference between flipping over the x-axis, flipping over the y-axis, and you are going to be asked to know, so that you're going to be asked questions so that I can figure out if you know how to transform the vertex, or in this case, this point right here, but you're not going to be thrown something quite as difficult as that. That's a lot of stuff. So thanks for sticking with me during that one. Okay, write the new equation of y equals x squared if it's shifted down 4 units. You're going to be expected to be able to do this, to look at a parent function equation and write a new equation given the transformations that are required. So simply down 4 units would be x squared minus 4. Here it shifted up 4 units and reflected over the x-axis. That reflected over the x-axis means a negative right after the equal sign. And the shifted up 4 units would just be plus 4. Here we've got y equals x squared if it shifted up 4 units and shifted to the right 7. Once again, if you want to shift to the left or the right, it comes after the x in the parentheses. So if it's to the right 7 units, we put the opposite. And if it's up 4, we're going to put plus 4, and we'll put a square. Did I forget my square on the other one? No, remembered it. Don't miss a half point on the test by forgetting your square. I know when we did marker boards today, a lot of people would forget their square. Don't do that on the test. Okay, so here's a square root equation, and it shifted down 3 and to the right 5 and flipped, it's been a long day, and flipped over the x-axis. So here we go. It's going to be, the first thing we're going to do is, if it's flipped over the x-axis, that negative is the one that comes right after the equal sign. Then if it's shifted to the right, then it's going to be x minus 5. I don't really need the parentheses underneath there. I'm not sure why I'm doing that. And down 3 minus 3. So you could write that without the parentheses in there. No problem. Okay, shifted down 1 to the left 4 and flipped over both the x and y axis. This one is going to be so much easier to write than we found ourselves with graphing. The graphing was pretty complicated. Here, if it shifts over both the x and the y axis, the negative follows the equal sign. That takes care of the x-axis flip. The y-axis flip comes before the x. And then what else is going on? To the left 4, so that's plus 4. And shifted down 1, that's minus 1. Whew, okay. Back to quadratics. If it shifted up 5 and to the left 3 and is more steep, then everyone's answer on this could look different. You could choose to put 100 here, or 5. We'll just put 5. And what else is it? To the left 3. So we'll do plus 3. Up 5. And what have I forgotten? It's flipped over the x-axis. That means I need a negative right after my equal sign. Okay, so back to a quadratic. It shifted down 4 to the right 5. All right, so let's see. And it's flipped over both the x-axis and the y-axis. Once again, it's easier to write than to graph. So we'll go ahead and put the negative right after the equal sign to get take care of the flip over the x-axis. And then we will put the negative in front of the x to take care of the flip over the y-axis. Then, let's see, it is to the right 5, so that's a minus 5, and down 4 is minus 4, and less steep. Okay, so I need to squeeze a number in here, or I'm just going to kind of move my negative a little bit further out. So less steep means I need to pick something that is in between 0 and 1, so I'll just pick a 0.5. So that it's less steep, it's wider than the parent function. Okay, so I'm hoping that you have fun with your homework and that you check your solutions and that you take the time to memorize the transformations and just get lots of practice. So thank you very much for listening, and I will see you in class.